Hello everyone, welcome to this walkthrough of the June 2024 A-Level Pure Mathematics exam paper. In this video, we will go through the questions step by step and discuss the best methods to solve them. I will explain the key concepts involved, the techniques you need to remember, and some common mistakes students make in the exam. This paper mainly tests core topics such as algebra, calculus, functions, trigonometry, and sequences. As we work through the questions, try to pause the video and attempt each problem yourself before looking at the solution. The aim is not just to get the answer, but to understand the reasoning and exam strategy behind each step. Let's begin with question 1. Question 1. Y equals 4x cubed minus 7x squared plus 5x minus 10. Find in simplest form dy over dx, d square y over dx square. Okay, so for this question, we know that if you have y equals x to the power n, then the differentiation of dy over dx will be n x to the power n minus 1. Okay, so let's differentiate this. So dy over dx will be 4x cubed. So x cubed differentiation will be 3x squared, and 3 times 4 will be 12x squared minus x squared differentiation will be 2x. So 2 times 7 will be 14x plus 5, and differentiation of a constant is 0. So this is dy over dx. Now second derivative will be, you differentiate this again, so 12x squared will be 24x minus 14, and differentiation of 5 will be 0. Now find the exact value of x when d square y over dx square equals 0. So for this we just write 24x minus 14 equals 0. So x will be 14 over 24. So if we divide this by 2, it will be 7 over 12. Okay, let's check the answer. So 14 over 24, 12x squared minus 14x plus 5. Yeah, all good. Question 2. Jamie takes out an interest-free loan of £8,100. Jamie makes a payment every month to pay back the loan. Jamie repays £400 in 1 month, £390 in 2 months, 380 in month 3, and so on, so that the amounts repaid each month form an arithmetic sequence. Show that Jamie repays £290 in month 12. Okay, so this is an arithmetic sequence. The first term is 400. The second term is 390. And then 380. So at some point it will be 290. So we have to prove that. So this is the first term, this is the second, and likewise this is the 12th term. We have to prove that this is the 12th term. So in this case, your first term a is 400. The common difference d will be 390 minus 400. So we do the second term minus the first term, which is minus 10. Now we have to prove that this is the 12th term. So let's work out. So there is a formula for the nth term of an arithmetic sequence. An equals a plus n minus 1 times d. If we say this is the 12th term, so either we two ways you can do this. Either you prove that this is you work out the 12th term, or you can work out the n for a equals 290. So let's say we put n equals 12 here. Both ways are correct. So a12 will be, first term a is 400 plus n is 12 minus 1 times d is minus 10. So if we simplify this, 400 plus 11 times minus 10. So it will be 400 minus 110. So this will give you 290. that means this is correct. Okay, now part B. After Jamie's nth payment, the loan is completely paid back. Show that n square minus 81n plus 1620 equals 0. So for part B, so this was part A. Now for part B, we'll just draw a line here. So for part B, we have to prove that the sum of, like, if we say the sum formula Sn, so Sn equals n by 2 times 2a plus n minus 1 times d. Now if we say the total amount that needs to be paid back is 8100, so if you just put 8100 here equals n divided by 2 times 400 plus n minus 1 times minus 10. Now this will be, you can divide each of the term inside, or let's take 2 common from this bracket, or just divide. 2 divided by 2 is 1, 2 divided by 2 is 1, and 10 divided by 2 will be minus 5. Minus 10 divided by 2 will be minus 5. So this becomes 8100 equals n times 400, and then expand the bracket, times minus 5 inside, so minus 5n plus 5. Then this becomes 8100 equals n times 405 plus 405 minus 5n. Now you expand the bracket, 405n minus 5n square. Now bring everything to one side, so 5n square, you change the sign, 5n square minus 405n plus 8100 equals 0. Now let's divide each of the term by 5. So 5 divided by 5 will be n square minus 5 times 8 is 40. So this will 81n plus 5 times 1 is 5, 31. 5 times 6 is 30. 5 times 2 is 10. So we'll get this quadratic equation, which is the same as this one. Now use calculator to solve for part C to work out the value of n. Use calculator to, so we go to the equation solver. So alpha A, I'm using my calculator, so depending on what calculator you have. So this one, the one I'm using is Casio FX991EX class Wiz. So it's fairly standard A-level calculator. So if I go to option A, then I have to select polynomial, then select degree 2, then you can select the value of ax squared plus bx plus c. So for A I will put 1, B I will put minus 81, and then C I will put 1620, and then hit solve. So that gave me two values of n. One is 36 and the other value of n is 45. So we'll reject this one and accept this one, the minimum. Like, so the answer to question C will be 36. Okay. Yeah, so the acceptable solution will be 36. Yeah, all correct. Good. Question 3. The point P 3, minus 2 lies on the curve with equation y equals fx, where x belongs to real numbers. Find the coordinates of the point to which P is mapped when the curve with equation y equals fx is transformed to the curve with equation y equals fx minus 2 and y equals f of 2x and y equals 3 times f of minus x plus 5. Okay, so let's have a look. So there is a point, the x coordinate is 3, y coordinate is minus 2, so x coordinate is 3, y coordinate is 3, so this is the point P. Now when we do f of x minus 2, the curve is shifted 2 units to the right. So if we shift 2 units to the right, then the new position will be, so this was x coordinate was 3, y coordinate was minus 2, so only the x coordinate will be like plus 2, so it will be 5 comma minus 2. Okay, now when you do f of 2x. Now again, when you do f of 2x, the y value, the x values will be multiplied by half. So you have 3 comma minus 2 here, b. Now when you do f of 2x, the x values will be multiplied by 1 over 2. So that means 3 becomes 3 divided by 2. So the new coordinates for b, so this is for I, and the new coordinates will be x coordinates. The y remains unchanged, so it will be here, and the new position will be 3 by 2, which is 1.5 comma minus 2. Y remains unchanged, so this will be the new position. Now the last one, you have a lot of transformations here. So what we will do is we will start with y equals fx. So we do f of minus x. Now when you do f of minus x, the point is reflected on the y-axis. If you do minus fx, then it will be reflected on the x-axis, but minus fx. So this point is here, which is 3 comma minus 2. Now if you do minus x, so you reflect on the y-axis, and the coordinates becomes minus 3 comma minus 2. So that's the first one. Then we times it by 3. So when you times it by 3, 3 times f of minus x, then the y values will be multiplied by 3. So the new coordinates becomes, so the x coordinate remains unchanged, so it will be minus 3 comma minus 2 times 3 will be minus 6. Now if we add plus 5, we shift the graph 5 units up, so the new coordinates will be minus 3 comma minus 1. So we add plus 5, so the new coordinates for I will be minus 3 minus 1. Okay, so this is for I, and this is for I, and this is for I. So let's have a look at the answers. So 5 comma minus 2, and then 1.5 comma minus 2, that's correct. This is correct. And the last one is minus 3 comma minus 1. So all are correct. Question 4. A sequence u1, u2, u3 is defined by un plus 1 equals k un minus 5, and u1 is 6, where k is a positive constant. Given that u3 is minus 1, show that this thing. Okay, so u1 is 6, so let's work out. Let's put n equals 1 here, so that will give you u1 plus 1 will be u2 equals k u1 minus 5. Now u1 is 6, so that means k6 will be 6k minus 5, so that's u2. Now let's put n equals 2 there, so it becomes u3 equals k u2 minus 5. Now u2 is this, so that becomes k times 6k minus 5 minus 5. So this is u3. Now u3 is minus 1, so I'll put this equals minus 1. Now we have to simplify this. So minus 1 equals, let's expand the bracket, so 6k square minus 5k minus 5. Now bring the minus 1 to the right, so that becomes 6k square minus 5k minus 5 plus 1 becomes minus 4, and the left hand side becomes 0. So that's what we were supposed to prove here. Now hence find the value of k. So let's solve this quadratic equation. So use calculator again. So your a is 6, b is minus 5, and c is minus 4. So a is 6, b is minus 5, c is minus 4. So that gave me two values of k. K equals 4 over 3 and k equals minus half. Now the question says that k is a positive constant, so we will reject this value here. So the acceptable value will be k equals 4 by 3. Okay, now find the value of summation r equals 1 to 3 ur. So you need to work out u1 plus u2 plus u3. So that's what summation means. Now u1 is 6, yeah, plus u2. u2 is 6k minus 5. So we do 6 times k is 4 over 3. 6k minus 5 plus u3. u3 is minus 1. So plus minus 1. So it will be just minus 1 here. So that will be 6 plus 3 times 1 is 3. 3 times 2 is 6. 2 times 4 will be 8. Minus 5 minus 1 is minus 6. So that will give you 6 minus 6 cancel. That will give you answer of 8. Let's check the answers. So this is 8 and k is 4 over 3. Perfect. Question 5. Given that theta is small and in radians, use the small angle approximations to find an approximate numerical value of theta times tan 2 theta 1 minus cos 3 theta. So first thing is we should know when theta is small and in radians, we can use small angle approximation. So sine A, if A is small, then this can be written as A. It can be approximated as A, and then tan A will be approximated A as well, and then cos A is 1 minus A square divided by 2. Now if A is theta, then sine theta will be theta. If A is 2 theta, sine 2 theta will be 2 theta. So like that. You just have to replace A for whatever angle theta is. So in here, let's use these approximations. So theta remains theta. Now tan 2 theta. So replace A with 2 theta. So it will be 2 theta. So times 2 theta over 1 minus cos theta. So cos 3 theta. So A is 3 theta. So you write 1 minus 3 theta whole square divided by 2. So numerator becomes 2 theta square. Denominator becomes 1 minus 1 plus 3 times 3 is 9 theta square by 2. So 1 minus 1 is 0. And then 2 theta square divided by 9 theta square becomes 2 theta square times 2 over 9 theta square. Now theta square cancel, and this becomes 4 over 2 times 2 is 4, 4 over 9. Okay, let's check the answer now. 4 over 9, that's correct. Question 6. Figure 1 shows a sketch of the curves with equation y equals fx and y equals gx, where fx is equal to e to the power 4x squared minus 1, where x is greater than 0, g of x is 8 ln x, x greater than 0. Find f dash x and g dash x. So before we do this question, if you have y equals e to the power x, then dy over dx is e to the power x. And if you have y equals ln x, differentiation of ln x is 1 over x. Okay, now this question here we have to apply chain rule. So if fx is e to the power 4x squared minus 1, so f dash x will be, so first you will assume that this is like capital X, and then it will stay e to the power 4x squared minus 1, and then we differentiate the function inside, which is, we can say, is u. So differentiation of 4x squared will be 8x. So this is f dash x, and g dash x will be 8 ln x. Differentiation will be 1 over x, so it will be 8 over x. Okay. Now f dash x equals g dash x at x equals alpha, so that alpha satisfies this equation. Okay, so f dash x is 8x e to the power 4x squared minus 1 equals g dash x is 8 over x. So first we divide both sides by 8. 8 divided by 8 is 1. 8 divided by 8 is 1. and we multiply x on both sides, so this will give us x square e to the power 4x square minus 1 equals 1. Now we take ln on both sides, ln, so ln x square e to the power 4x square minus 1 equals ln 1. Now ln 1 is 0, and here we can apply ln a times b equals ln a plus ln b. So this becomes ln x square plus ln e to the power 4x square minus 1. Ln x square becomes 2 ln x plus ln e to the power 4x square minus 1 becomes just 4x square minus 1. Ln e will be 1 equals 0. If we rewrite this, then this becomes 4x square plus 2 ln x minus 1 equals 0. So that's what we were meant to prove. That's correct. Now the iterative formula. So they gave us the iterative formula here is used with x1 is 0.6. Find an approximate value for alpha. Okay, so the iterative formula is used to find an approximate value for alpha. Calculate giving each answer to 4 decimal places the value of x2. So for this, what we will do is we will first type 0.6 in the calculator and press equal. Now what this will do is it will store 0.6 in the answer. Now we will use this iterative formula, so square root, and then on the numerator 1 minus 2 times ln, and then we put answer there, bracket closed, and in the denominator is 4. So this way it gave me x2 equals 0.710923914. So we need to give the answer to 4 decimal places. So yeah, this will be the answer. Now find the value of alpha. So what we will do here is, so in your calculator keep pressing equal. So let's say if I press equal again, so I'm getting 0.6485. Press equal again, I'm getting 0.6830. Press equal again, this gives us 0.6637. So these values are changing, so at some point they will stop changing. That's what we need to work out. So keep pressing equal, 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 equal. I still don't see, like, after so many presses I'm getting 0.6704. Then press equal again, 0.6707, 6705, 6706, 6706, 6706, 6706, 6706, 6706. So it stopped changing at 0.6706. So we can say that alpha is 0.6706. Let's check the answers. Yeah, this is correct. 0.7109. Yeah. And of course this is correct, and these are correct as well. Yeah, we don't need to write in this one. If you leave it like this, it's okay. Okay, well done. Question 7. Figure 2 shows a sketch of the straight line L. The line L passes through the points A and B relative to a fixed origin O. The point A has position vectors 2i minus 3j plus 5k. The point B has position vectors 5i plus 6j plus 8k. Find AB vector. So let's say this is vector O. We join this here, and if we join this here, so that's your O. So OA is 2i minus 3j plus 5k, and OB is 5i plus 6j plus 8k. Now we need to find out the AB vector. So we'll use the triangle of vector addition. So you can write AB vector. So from A, starting at A and pointing towards B, So to go from A to B, we will go from A to O. So it will be AO vector plus OB vector. Now AO vector will be same as minus OA vector plus OB vector. Now if we just add them, so AB vector will be minus OA will be 2i minus 3j plus 5k plus OB, which is 5i plus 6j plus 8k. Okay, so now if you simplify, expand the bracket, so minus 2i plus 3j minus 5k, we multiply this minus sign inside, plus 5i plus 6j plus 8k. Now if you simplify, 5i minus 2i will be 3i, 6j plus 3j will be 9j, 8k minus 5k will be plus 3k. So that will be the vector AB. Now part B, given that point P lies on L such that the magnitude of AP is twice the magnitude of BP. Okay, so find the position vectors of P. Okay, so I'll change the color for this question of my pen. Okay, so I use blue. Okay, so there are two possibilities. So the magnitude of, so P can be, let me change a different color, I think more highlighting one. Okay, so point P can be here, so that's one possibility, because in this case AP will be twice BP. Okay, or the other possibility is the P is here and P is here and AP is twice BP. I mean the magnitude, they are different directions, but the magnitudes are like that. So this is one part, this is two parts, so there are two possibilities. So let's consider the possibility of this one first. Now if this is the case, then you can write AP vector. So if we consider, let's say this one, we can call it as just call it as P. So P far, let's say, and this is P near. So P far, this point here, AP will be twice as BP, which means that AB and BP will also be the same. So AP vector can be written as twice AB vector. So this becomes AP vector will be twice AB. AB you have already calculated, so 3i plus 9j plus 3k. So that will be one possibility if you consider the farthest point here. So PF, we are talking about the far point. So this becomes 6i plus 18j plus 2 times 3 is 6k. Okay, now we need to work out. So if we look at OP, we need to work out the position vector of P. So OP vector will be, for the farthest far point, OP vector will be OA plus AB, AP, OA vector plus AP vector. So OA is, we already know, is 2i minus 3j plus 5k, plus AP vector we have calculated here will be 6i plus 18j plus 6k. Now if we simplify, 6 plus 2 is 8i, 18j minus 3j will be 15j plus, and 6k plus 5k will be 11k. So double check again. So we multiplied by 2, so 6i plus 18j plus 6k, and then we add, oh, so 2 plus 6 is 8, 18 minus 3 will be 15, 6 plus 5 11. So that's the for the far. Now if we consider the near position here, so if we consider this one here, then this is 1:2. So AP vector in this case will be, so this is two parts, this is one part, so 2 out of 3. So we can write 2 out of 3 AB. So AP vector will be in this case 2/3 of AB vector. So 2/3 of AB. AB is 3i plus 9j plus 3k. 3i plus 9j plus 3k. So that's so that's AP. So this will give you, we divide by 3, so 3 divided by 3 is 1, 3 divided by 3 is 1i plus 3j plus 1k. 3 times by 2, so it will be 2i plus 2 times 3 is 6j plus 2k. So 2i plus 6j plus 2k. So that's AP vector. Now again, if you see OP vector in this case, now for the near point, OP vector will be OA plus AP. OP vector will be, again, as you can write it as OA vector plus AP vector. This is for the near point, okay, when P is in between A and B. So OA vector is, we have OA as 2i minus 3j plus 5k, 2i minus 3j plus 5k, plus AP vector, which is this one now. So 2i plus 6j plus 2k. Now if we add 2i plus 2i is 4i, 6j minus 3j will be plus 3j, 5k plus 2k will be plus 7k. Okay, so this is the when P lies in between, and this is when P lies away from B. Okay, let's check the answers. So 3i plus 9j plus 3k for AB, 3i plus 9j plus 3k, that's correct. Then 8i plus 15j plus 11k, that's correct. Yeah, and 4i plus 3j plus 7k, 4i plus 3j plus 7k. Yeah, so both correct. Perfect. Question 8a, prove that 1 over cosec theta minus 1 plus 1 over cosec theta plus 1 can be written as 2 tan theta sec theta, where theta belongs to this. Okay, so what we do is we will first make denominator the same. So cosec theta minus 1. We don't even need to write like this, but just for simplicity I'm writing this. So we multiply by cosec theta plus 1 on both numerator and denominator on the first fraction, plus 1 times cosec theta minus 1 over cosec theta plus 1 times cosec theta minus 1. Now we have the same denominator, and this is a minus b times a plus b, so the denominator can be written as cosec square theta minus 1. Okay, a minus b times a plus b is a square minus b square. Now numerator will be cosec theta plus 1 plus cosec theta minus 1. So this plus 1 and minus 1 cancel. This becomes 2 cosec theta over cosec square theta minus 1. Now there is a trig identity. Cosec square theta can be written as 1 plus cot square theta. So we'll use this and substitute here. So this can be written as 2 cosec theta over cosec square theta is 1 plus cot square theta minus 1. So this 1 and minus 1 will cancel out, and this becomes 2 cosec theta over cot square theta. This can be written as 2 cosec theta is 1 over sine theta, so 2 over sine theta, and 1 over cot square theta can be written as tan square theta. Now we have to try to get this thing. So there is a tan theta already there, so I will write 1 of the tan theta as it is, and 2 tan theta over sine theta. So tan square theta can be written as tan theta times tan theta. So this tan theta and the other tan theta I will write it as sine theta over cos theta. Now this sine theta cancel. So this becomes 2 tan theta over cos theta, and 1 over cos theta can be written as 2 tan theta sec theta. So that was we were supposed to prove. So this is one way of doing this, but you could have simplified the left hand side, and same time you have simplified the right hand side, and then you will end up having the same things on both left hand side and right hand side. But if you want to just simplify the left hand side, that's how you will do this. Okay, so that's part A. Now let's have a look at the part B. Hence solve for x between 0 and 90, the equation. So this is the equation you need to solve. So this part here is the same as this one, just theta is 2x here. So we will replace with this identity now. So the left hand side can be replaced as 2 tan 2x sec 2x equals cot 2x sec 2x. Bring everything to one side. Rather than cancelling sec 2x, we bring everything to one side and factorize. So 2 tan 2x sec 2x minus cot 2x sec 2x equals 0. Now we factorize. So sec 2x 2 tan 2x minus cot 2x equals 0. That means either, sorry, this is x, 2x. Now either this is 0 or this 0. Now sec functions, they are always like either greater than 1 or less than -1. So there is nothing between +1 and -1. So it's not possible for sec 2x equals 0. So we will reject the solution for this one. That means the only possibility is 2 tan 2x minus cot 2x equals 0. Now cot 2x, let's write it down as 1 over tan 2x. So this becomes 2 tan 2x minus 1 over tan 2x equals 0. Now let's multiply by tan 2x on both sides. So this becomes 2 tan squared 2x minus 1 equals 0. Okay, that means tan 2x, tan squared 2x will be 1 over 2. If you simplify this, that means tan 2x will be plus minus 1 over square root of 2. Now x varies between 0 to 90, so let's multiply this domain by 2. So this becomes 2x greater than 0 less than 180, and let's call 2x as alpha. So alpha is between 0 and 180, and this becomes tan alpha equals 1 over root 2, or tan alpha equals minus 1 over root 2. Now if you remember the graph of tan function, so between 0 to 180 the graph will be something like this. So this is 0, this is 90 degrees, this is 180 degrees, so the graph will be like this. Now let me change the color of my pen. So 1 over root 2 will be this solution here, and minus 1 over root 2 will be this solution here. So let's work out the first positive solution, 1 over root 2. So tan inverse 1 over root 2 gives us, let me use my calculator, shift tan inverse 1 divided by square root of 2. That gave me 35.26. So this is the value of alpha. That means x will be 2x is alpha. That means x will be alpha divided by 2, which is, if you divide this by 2, that gave me 17.6. So we have to give the answer to one decimal place. So one of the solution will be 17.6 degrees. Now the other solution will be, now we can use the symmetry of the graph, because this is 1 over root 2, this is minus 1 over root 2. So from this 0, you are going 17.6 degrees to the right to get to this point. Therefore from 180, from this 0 you're going 35.26. We're talking about alpha. So from 180 you will go back 35.26. So we do 180 minus 35.26. that gave me 144. So the other value of alpha will be 144.74, and if you divide this by 2, that will give you the value of x. So the other value of x will be 72.4 degrees. So the answer may vary a little bit, but I think these two answers are correct. Let's have a look. So 17.6, that's correct, and 72.4, that's both correct. Yep, perfect. So this is probably the simplest way to do this question. I think the mark scheme looks a bit messy here. Yes, quite messy. So just keep it simple. Use this method. Perfect. Question 9. The graph in figure 3 shows the path of a small ball. The ball travels in a vertical plane above horizontal ground. The ball is thrown from the point represented by A and caught at the point represented by B. The height h in meters of the ball above the ground has been plotted against the horizontal distance x meters measured from the point where the ball was thrown. With respect to a fixed origin O, the point A has coordinates 0, 2 and the point B has coordinates 20, 0.8 as shown in figure 3. The ball reaches its maximum height when x is 9. So this is x equals 9, this one here. A quadratic function linking h with x is used to model the path of the ball. Find h in terms of x. So this is a quadratic function, and we can see there is a maximum value here. So, and is like downward facing quadratic function. So we can assume h equals minus a times, because this is facing the other way around, so minus a times x minus b whole square plus c. So this is a complete square form for this kind of function. If we could have done this with like assuming h equals ax square plus bx plus c, and then used all the conditions there to work out the values of a, b, and c. Now the maximum height will be, so this is a complete square form, so the maximum height will be when x is 9, so the maximum height will be when this is 0. Okay, so when this is 0, then this will be, the maximum height will be equals to c. So here that means when x is 9, that's the maximum height, so that means x equals 9, or you can write this as x minus 9. So when x is 9, then that will give you h equals c. So that means b is 9. Okay, now let's use these conditions. So 0, 2, so x is 0 and h is 2, and here x is 20 and h is 0.8. So we use these two conditions to work out the value of a and c. So let's use the first one. So when x is 0, h is 2. So we write 2 equals minus a, and x is 0, so minus 9 whole square plus c. So this becomes 2 equals, minus 9 square is 81, so minus 81a plus c. So that's one equation. Now we will get a similar equation using the other condition. So when x is 20, h is 0.8, so you write 0.8 equals minus a times 20 minus 9 whole square plus c. So this will give you 0.8 equals minus a. 20 minus 9 is 11, and 11 squared is 121 plus c. So this will give us 0.8 equals minus 121a plus c. So this is our equation number 2. Now if we solve these two equations, so basically if we subtract 1 minus 2, then 2 minus 0, so we do 2 minus 0.8, that will give you 1.2 equals minus 81 minus 121a. So that will give us 1 minus 81 plus 121. So 121 minus 81 is 40. So this becomes 40a. That means a is 1.2 divided by 40. So that gave us a is 0.03. Now a is 0.03. If we substitute the value of a in one of these equations, let's substitute in the first one. So this becomes 2 equals minus 81 times 0.03 plus c. So that becomes 2 equals minus 81 times 0.03 minus 81 times. So we do 2 plus, basically if we move this thing to the left, becomes plus 2 plus 81 times 0.03. That gave us the value of CS. So C from here comes out as 4.43. Okay, so let's write down the equation again. So H equals minus 0.03, so that's A, times X minus 9 whole square plus 4.43. So this form is quite useful because you can see that the maximum height, if they have asked find the maximum height, then the maximum height will be 4.43. And yep, so that's answer to part A. We can expand this, like you can have it in the form ax squared plus bx plus c, but I think this is acceptable. We can expand. Let's try to expand just in case. We'll probably be using this form for later questions. So if we expand this minus 0.03, then x squared plus, when you expand x minus 9 times x minus 9 will be x squared plus 81 minus 18 x plus 4.43. Now if we expand this, so minus 0.03 x squared and then minus 0.03 times 81 plus 4.43, that gave me 6.43. So plus 6.43, and then we do minus 0.03 times minus 18. So that comes out as, so minus minus becomes plus, so it will be plus 0.54x. That's another form of H. You can quickly check the answer. Okay, so 1 second. So there's some mistake here. Minus 0.03 times 81. So if we do minus 0.03 times 81 is minus 2.43 plus 4.43 is 2. Yeah, so yeah, this should be 2. Yeah, this one. I probably made some mistake in typing. Okay, so this is plus 2. But probably be best to leave it like this because it's quite useful. Now give one limitation of the model. So the motion is only taking place from the point where the ball was released and the ball where the ball was caught, so only from A to B. So we only can comment about the motion from A to B. Okay, so what we can say is that like limitation will be like, we probably assume that it's a vertical path, vertical plane, which may or may not be possible depending on the wind. Also the shape of the ball, if it's perfectly round or not round, will shape the motion, the path of the motion. Or what else we can say about limitation? We probably have assumed that the ball is like a point, yeah, like a particle. So we can ignore that if it's not, like in reality the ball is not a particle, it's a 3D object. So yeah, you can write one of these points, I think is acceptable. Okay, now the last part is Chandra is standing directly under the path of the ball at a point 16 meter horizontally from O. So yeah, so X is 16 basically. So Chandra can catch the ball if the ball is less than 2.5 meters above the ground. So let's use the model and work out the height of the ball when x is 16. So minus 0.03 times 16 minus 9 whole square plus 4.43. So 16 minus 9 is 7. So minus 0.03 times 7 square plus 4.43. So we do minus 0.03 times 7 square is 49 plus 4.43. So that comes out as 2.96 meters, which is more than 2.5 meters. So Chandra won't be able to catch the ball. So no. Yeah, let's check the answer quickly. So Chandra would not be able to catch the ball. Yeah, perfect. Question 10. Figure 4 shows a sketch of the curve C with parametric equations. X equals t plus 3 whole square, y equals 1 minus t cubed, where t is between minus 2 and plus 1. The point P with coordinates 4, 2 lies on C. Using parametric differentiation, show that the tangent to C at P has equation 3x plus 4y equals 20. Okay, so this is the point where we have to work out the equation of the tangent. So first let's work out what is dy over dx. So dy over dx, so in case of parametric equations, if we divide both numerator and denominator by dt, then dy over dx can be written as dy over dt over dx over dt. Okay, so we just have to differentiate the numerator and differentiate the denominator. So y differentiated with respect to t will be differentiation of 1 will be 0 and minus t cube will be minus 3t square over differentiation of x. So this will be 2 times t plus 3. Okay, so differentiation of x to the power n is n x to the power n minus 1. So that's what we have used here. So this is the this is dy over dx. Now we need to work out the value of dy over dx. So the point P has coordinates 4, 2. So x coordinate is 4. So x equals t plus 3 square. So x is 4 equals t plus 3 whole square. So this will give you t plus 3 equals square root on both sides will give you plus 2 and minus 2. So if we say plus 2, then t will be minus 1. And if we say t plus 3 equals minus 1, then t will be minus 4. Now minus 4 is outside this domain, so we reject this one, we accept this one. So when t is minus 1, the x coordinate will be minus 1 plus 3. 3 minus 1 is 2. 2 square is 4. Yeah, we already know that x coordinate is 4. Yeah, so we don't need to work out that. So t is minus 1. We can also check, like if we put 1 minus t cube equals y coordinate is 2. So if we put 2 here, then 1 minus 2 equals t cube. So we take the t minus t cube to the right and bring the plus 2 to the left. Then t cube becomes minus 1. Then t will give you minus 1. So both of them are giving us minus 1. So that's the acceptable solution. That means we just have to put dy over dx. In dy over dx, we have to put t equals minus 1. So this will be minus 3 times minus 1 square over 2 times minus 1 plus 3. So this will be minus 3 over 2 times 3 minus 1 will be 2. 2 times 2 will be 4. So the gradient dy over dx is the gradient at the point P, which is 4, 2. 4, 2 will be roughly somewhere. X coordinate is 4, y coordinate is 2 will be roughly, we don't know where exactly, but let's say if this is 4, x coordinate is 4 and y coordinate is 2. So this is, yeah. So at this point we worked out the tangent. So the gradient of the tangent is this. Now to work out the equation, we can use y equals mx plus c form. So y equals m is minus 3 over 4 x plus c. Now this point is on this line, so let's satisfy this point. Substitute this point x4 y2. So this becomes 2 equals minus 3 over 4 times 4 plus c. So 4 cancel and take the minus 3 to the left. That will give you c equals plus 5. That means the equation is y equals minus 3 by 4 x plus 5. Let's multiply by 4 on both sides, so that will give you 4y equals minus 3x plus 5, and then bring the minus 3x to the left, so that will give you 3x plus 4. So this will be 20. Sorry, when you multiply by 5, this will be 20. So 3x plus 4y equals 20. So that's answer to part A. Okay. Okay, now the curve C is used to model the profile of a slide at a water park. Units are in meters, with y being the height of the slide above water level. Find, according to the model, the greatest height of the slide above the water level. So we have to use this function to work out the maximum height. Now y will be the one that gives us the height. So if we can work out the maximum value of y in this interval, that will be the maximum height. Okay, so if we put t minus 2 here, 1 minus minus 2 cubed, that will give you 1 minus minus 8, and that will give you 1 plus 8 equals 9. So any other values of t in this interval will give you a value smaller than 9. So the maximum height will be 9. Let's check the answers. Yeah, that's 9 meters. Yeah, this is in meters, so you can say that's in 9 meters. Question 11. Figure 5 shows a sketch of part of the curve C with equation y equals 8x squared e to the power minus 3x, where x is greater than or equal to 0. The finite region R, which is this region here, this one shown shaded in figure 5, is bounded by the curve C, the line with equation x equals 1. The x-axis. Find the exact area of R, giving your answer in the form a plus b e to the power minus 3, where a and b are rational numbers to be found. Okay, so it looks like we have to integrate to find the area under the curve, and bounded by x equals 0 and x equals 1, and the x-axis. So it looks like when we integrate, we are going to use integration by parts. So just a quick reminder of the integration by parts formula. Integral u v dash dx equals u v minus integral v u dash dx. So that's integration by parts. Now to work out this area, we will write integral. So r will be equal to integral 0 to 1 y dx, where y is integral 0 to 1 8x squared e to the power minus 3x dx. Let's take the 8 out, and this becomes 0 to 1 x squared e to the power minus 3x dx. Now let's call this as I. Okay, so let's work out the value of I. So I equals, so we say this is your u and this is your v dash. So u is x squared and v dash is e to the power minus 3x. Now u dash will be, you differentiate this, so it becomes 2x, and v will be, this becomes, so this is like f dash. So if you know f dash ax plus b form, if you integrate this, this becomes 1 by a f of ax plus b plus constant. So we integrate e to the power minus 3x as 1 over minus 3 e to the power minus 3x. Okay, now to work out I, remember to multiply 8 at the end. So I becomes u times v. So this is I. U is x squared and v is 1 over minus 3 e to the power minus 3x. So that's uv minus integral v is 1 over minus 3 e to the power minus 3x, and u dash will be 2x dx. Okay, we further simplify this, so we can write this as minus x squared by 3 e to the power minus 3x, and take the 1 by 3, 2 and 1 by minus 3 out, so it becomes plus 2 over 3 integral x e to the power minus 3x dx. We are not using the limits at the moment. We will first integrate and then we will substitute the limits later on. So let's call this part here as 2. Okay, now I'll go in the next page. So integral x e to the power minus 3x dx, that's your II. Yep, x e to the power minus 3x dx. Now we need to integrate this, so we have to use the integration by parts again. So that's your u, that's your v dash. So u dash will be 1 and v will be, you integrate e to the power minus 3x, so minus 1 over 3 e to the power minus 3x. Okay, now we use integration by parts formula, so I can be written as u times v. U is x and v is minus 1/3 e to the power minus 3x, and then minus integral v is minus 1 by 3 e to the power minus 3x, and u dash is 1 dx. Okay, so it looks better now. So minus x over 3 e to the power minus 3x, and minus minus becomes plus, take the 1 by 3 out, and integral e to the power minus 3x dx. So this is quite easy to integrate now. So this becomes minus x over 3 e to the power minus 3x, and then this becomes 1 by minus 3 will be out again, so it becomes minus 1 over 9. So 1 over 3 times 1 over minus 3 will be minus 1 over 9 e to the power minus 3x. Okay, so that's your II. Now let's go back here. So your I was, so let me change the color of my pen just to keep it simple. So I was, you write it down, minus x squared over 3 e to the power minus 3x plus 2/3, and then this is II, or second, you can call it second. So you can write down here this thing. So minus x over 3 e to the power minus 3x minus 1 over 9 e to the power minus 3x. It looks like we can pull e to the power minus 3x common. So it becomes e to the power minus 3x. Yes, we can take e to the power minus 3x common. And then this becomes minus x squared by 3. Yep. And 2 by 3 times minus x by 3 will be minus x over 9 minus 2x over 9. So there's 2 as well. Minus 2x over 9, and then minus 2 over 27. Okay, so that's your I, and then you have to multiply it by 8 as well, and we can put the limits now 0 to 1. So it becomes 8 times, when you put 1 it becomes e to the power minus 3, and minus 1 over 3 minus 2 over 9 minus 2 over 27 minus 8 times, you put 0, e to the power 0 is 1, and this becomes minus 2 over 27. Now let's simplify. So minus 1 divided by 3 minus 2 divided by 9 minus 2 divided by 27. that gave me minus 17 over 27, and if we times by 8, that gave me minus 127 over 20, no, minus 136, sorry, 136 over 27 e to the power minus 3, minus becomes plus, 8 times 2 is 16 over 27. That means a will be 16 over 27 and b will be minus 136 over 27. Okay, so this question is about integration by parts twice. So let's check the answer now. So 16 over 27, that's correct, and minus 136 over 27, that's perfect. Yeah, so that's how we will do this question. Question 12a, express 1 over v times 25 minus v in partial fractions. Okay, so first thing we will do is we will write 1 over v times 25 minus v equals a over v plus b over 25 minus v. Okay, now we make the same denominator and then we compare the numerator. So 1 equals a, so this will be multiplied by this, v will be multiplied by 25 minus v, so a will be multiplied by 25 minus v, plus b will be multiplied by v. Okay, and we compare the numerator, so we have the same denominators on both sides, so we just compare the numerators. Now we use substitution here, so if we put v equals 0, then this becomes 1 equals 25a, that means a equals 1 over 25. And if we put v equals 25, then 1 equals, now this becomes 0, then it becomes b times 25, so b is also 1 over 25. So this becomes, a is 1 over 25, so you can write 1 over 25 v plus 1 over 25 times 25 minus v. Okay, or you can take 1 over 25 common, then it can be written as 1 over v plus 1 over 25 minus v. So that's the answer to part A. Now the volume v microliters, so the unit of v is microliters here, of a plant cell t hours, so t is in hours. It's very important to read the units carefully when we are doing differential equation related questions like this one. So t hours after the plant is watered is modeled by the differential equation dv over dt equals this. So the plant cell has an initial volume of, so when t is 0, so this is for part B, when t is 0, v is 20 microliters. Find, according to the model, the time taken in minutes for the volume of the plant cell to reach 24 microliters. We need to work out t when v is 24. Okay, and t must be in minutes. Okay, so what we do is we will first take this differential equation and separate the variables. So we separate the v, so bring the v and 25 minus v to the left and take the dt to the right, so 1 over 10 dt. So we just separate the variables, then we integrate on both sides. Now to integrate 1 over v times 25 minus v, this can be written as, you write 1 over 25, 1 over v plus 1 over 25 minus v. So we take the 1 over 25 out, and this becomes integral 1 over v plus 1 over 25 minus v dv equals, this becomes t over 10 plus c. Now this becomes 1 over 25 and 1 over v integration becomes ln v. We don't need to put modulus. When we are doing differential equations, we don't need to put the modulus sign here. And this becomes minus ln 25 minus v equals t over 10 plus c. Let's multiply by 25 on both sides, and this one, this is ln a minus ln b, can be written as ln a over b. So this can be written as, so we multiply 25 first, so this becomes ln v over 25 minus v equals, so this becomes 25 over 10, which is 2.5 t plus 25 times c. Let's call it as another constant d, doesn't matter, it's just a constant, or you can call it as k. Okay, so this is what we have at the moment. We still need to work out the value of k here, and then we will work out the value of t when v is 24. So let's use the first condition, t is 0. If we put t 0 here and v 20, then this becomes ln 20 over 25 minus 20 will be 25 minus 20 equals 2.5t, 2.5t, t is 0, so we do times 0 plus k, so this becomes 20 over 5, which is ln 4 equals k. Okay, that means if we rewrite the equation, so ln v over 25 minus v equals 2.5t plus k. K is ln 4. Right, now we just have to put v24 here and then work out the value of t. So now if we put, when v is 24 microliters, so ln 24 over 25 minus 24 will be 1 equals 2.5t plus ln 4. So this becomes ln 24, and bring the ln 4 this side, minus ln 4, and divide by 2.5. So this will give us t. So let's work out the value of t. So ln 24 over minus 4 becomes ln 24 divided by 4, which is ln 6 over 2.5. So that will be the value of t. So ln 6 divided by 2.5. So that gave me 0.7167 hours. If I times this by 60, that gave me 43.0022. So just let's say 43 minutes. So that will be the answer for answer to part B. Okay, now show that this is the equation. Okay, now we have the equation here, and we have to rearrange this to write it in this form. So let's write ln v over 25 minus v and bring the 4 to the ln 4 to the left equals 2.5t. So we want e to the power minus kt. This, don't get confused with this k, in this case any constant, random constant. So this becomes ln v over 25 minus v divided by 4, which can be written as 1 over 4. So, or you can say this is 4 like this, equals 2.5t. Now this can be written as v over 4 times 25 minus v equals e to the power 2.5t. Okay, now we do the reciprocal here, so you can write 4 times 25 minus v over v equals e to the power, so this becomes 1 over e to the power 2.5t, which becomes 1 over which can be written as e to the power minus 2.5t. Okay, now expand this, so that becomes 100. 4 times 25 is 100 minus 4v over v, yeah, equals e to the power minus 2.5t. Yeah. Now let's divide each of the terms on the numerator. So 100 divided by v minus 4v divided by v will be just 4 minus 2.5t. So add 4 to both sides. So 100 over v equals e to the power minus 2.5t plus 4. Now do the reciprocal again. So you can write v over 100 equals 1 over e to the power minus 2.5t plus 4, and less times by 100. So v can be written as 100 over e to the power minus 2.5t plus 4. So that will be the final answer, where a is 100 and b is 4 and k is 2.5. Okay, now the model predicts that there is an upper limit L microliters on the volume of the plant cell. Find the value of L, giving a reason for your answer. Okay, now to find the maximum value of this function, so this is the e to the power minus. Now if you think about e to the power minus x function, the minimum value, so this is e to the power minus x, so the minimum value is 0. So what we want is we want the minimum denominator, and that will give the maximum value of v. So this term will tend to 0. So if we replace 0, then we will get the upper limit for b upper limit. V upper will be 100, and this will tend to 0 plus 4. So that will give us 100 divided by 4 is 25 liters, microliters. Yeah, let's check the answers now. So we got 43 minutes. Yes, so we got 43 minutes, and this is 1 over 25. Yeah, that's correct. This is correct. And then 25 microliters, and this is the function. So all correct. Very good. Okay, that's it. Question 13. The world human population p billions is modeled by the equation p equals ab to the power t, where a and b are constants and t is the number of years after 2004. Using the estimated population figures for the years from 2004 to 2007, a graph is plotted of log p to the base 10 against t. The points lie approximately on a straight line with gradient 0.0054, intercept 0.81 on the log p to the base 10 axis. Estimate to 3 decimal places the value of a and the value of b. Okay, so first let's start with this model. P equals ab to the power t. Now if we take log on both sides, so log p to the base 10 equals, and then we can apply the log identity here. So log, what you call log formula. So log, this becomes log a plus log b to the power t. Okay, and base is 10 for all of them. So this becomes log p to the base 10 equals, let's take the t to the front. So you can write log 10 pt. So I just write it like this. So t will go to the front, plus log a to the base 10. Okay, so now this, if we plot the graph of log p versus t, we can say this is y equals m x plus c. So if we sketch the graph, so this is your log p to the base 10 versus t, and this value here will be the log, like the y-intercept, log a to the base 10, and the gradient of this line will be m equals log b to the base 10. Okay, now they gave us some information here. So the gradient is 0.0054, so we can write log 10b equals 0.0054. That becomes b equals 10 to the power 0.0054. Now we have to give the answer to 3 decimal places, so we can work out what is 10 to the power. Use calculator. 0.0054, so that gave me to 3 decimal places 1.0125, which is 3. So 3 decimal, so this will be the value of b, and the intercept is 0.81. So log a to the base 10 can be written as 0.81. Then a can be written as 10 to the power 0.81 or 81. So 10 to the power 0.81 gives me 6.456. No, 6.6457, because this is 6.5. Yeah, so 6.4. So a is 6.457. That's the value of a, and that's the value of b. Okay. Now, in the context of the model, interpret the value of the constant a and interpret the value of the constant b. So when t is 0, then can you say p equals ab to the power 0, ab to the power 0, which is just a. So that means a is the population in the beginning. So a is the population in 2004. So a represents the initial population or the population in 2004. In the year 2004. Okay, now interpret the value of the constant b. So b is like, if you have, think about b equals ab to the power t. When t is 1, then b is ab to the power 1, and then t is 2, p will, like we are like checking every at the end of each year, not like all the time, but like not a continuous function, every year. So now when t is 2, this becomes a b to the power 2. So that means we have multiplied by b here, and then when you put t equals 3, then p becomes a b cube, which is again multiplied by b. So you can say that b is yearly scale factor, yearly scale factor for the population. So every year the population is scaled by this factor b. Okay, now use the model to estimate the world human population in 2030. So now the model is p equals a. We have calculated a as 6.457. No, 6.457 times b. B is 1.013 to the power t. So t now is 2030. So from 2004 to 2030 will be 26 years. So we just put t equals 26 here. So 6.457 times 1.013 to the power 26. That gave me 9.034 billions, because p is in billions. So roughly 9 billion, yeah, approximately. Now comment on the reliability of the answer to part C. Now this is in 2030. Now the model, the data used was only from 2004 to 2007. So it will be difficult to predict if the population will continue to follow this model by 2030, because we only have the data. The data used for this model was from 2004 to 2007. So we can't say anything. We can say that the model is not reliable because we don't know what will happen by 2030. We only use the data from 2004 to 2007. Okay, let's have a look at the answers quickly. So B is 1.013, A is 6.457. Yeah, that's all correct. And then roughly 9 billion. Yeah, that's correct. Yeah. And then not reliable, yeah, because we don't know what will happen in 2030. Yep. Question 14. Circle C1 has equation x squared plus y squared minus 6x plus 14y plus 33 equals 0. Question A. Find 1. The coordinates of the center of C1 and the radius of C1. Okay, so for this question, we just need to use complete square form. So complete square form is if you have x squared plus bx plus c, then complete square form is x plus you do half of b, x plus b by 2 whole square minus b by 2 whole square plus c, because we don't do anything to c. Now here, if we rewrite this as x squared minus 6x plus y squared plus 14y plus 33 equals 0. Now use the complete square form above, so this can be written as x minus 3. B is minus 6 here, so half of b will be minus 3. So x minus 3 whole square minus 3 whole square plus, in this case for y, it's b is 14, so it will be y plus 7 whole square minus 7 whole square plus 33 equals 0. So x minus 3 whole square minus 9 plus y plus 7 whole square minus 49 plus 33 equals 0. So x minus 3 whole square plus y plus 7 whole square, and then minus 9 plus minus 49 will be minus 58. Minus 58 plus 33 will be minus 25. And if we take minus 25 to the right hand side, you can write 25 on the right hand side. Now if we compare this with the standard form of circle, which is x minus a whole square plus y minus b whole square equals r square, that will give you the center of the circle as, so the center will be 3 and minus 7, and the radius is square root of 25, which is 5. Okay, so that's part A. Now let's talk about part B. So the center for part A is, you can write it down again, 3 and minus 7, and the radius is 5. Okay, now a different circle C2 has center with coordinates minus 6 and minus 8. Minus 6 and minus 8 has a radius k, where k is a constant. Given that C1 and C2 intersect at two distinct points, find the range of values of k, writing your answer in set notation. Okay, so let's try to sketch the diagram for this question. It's not necessary, but it helps. So the center for this one is 3 and minus 7, so x coordinate is 3, y coordinate is minus 7, and the radius, so this is the center. It's just a rough sketch. So radius is 5, so this is 3, this is 7, radius is 5, that means you do 5 up 2 more here. So this is the maximum. So if I draw this, so the circle will look like something like this. Okay, so that's circle C1. Now let me change the color of my pen. Let's use blue for this one. So now the other circle has center minus 6, so x coordinate is minus 6, so let's say minus 6 is here, and this was minus 7 here. The y coordinate is minus 8, so it will be somewhere here. So the center of the circle is here. Now the center of the other circle was here. So this is minus 6 and minus 8. Now given that these two circles intersect, okay, so now if the two circles intersect, so let's try to work out the distance between the centers of the circle. So let's say the distance between the centers will be this one. So to work out the distance between the center, let's call it as d. So d will be square root of, so this is 3 comma minus 7, so it will be 3 minus 6 whole square plus minus 7 minus 8 whole square. So this becomes square root of 3 plus 6, 9 square, plus minus 7 plus 8 will be plus 1 square. So will be square root of 81 plus 1, 9 square is 81, so will be square root of 82. So the distance between the two circles is square root of 82. Now if we think about, if the radius of, so this is radius r, not the radius r, like if we think about like the radius, so this is the distance between the two centers. Now if the radius, so this is 5 here, this is the radius of this circle. Now if the radius of the other circle is, like, if you consider this distance, now if this distance, which this will be square root of 82 minus 5, if the radius of this circle, so the radius is k in this case, so k, let's call it as k. So k must be, if k is bigger than this distance, then the radius, like the circle will, like if the radius is more than this distance, then k will, like the circle will intersect the other circle at two distinct points. And if we consider the farthest point from this point here will be 5 plus 5, so this, the radius of the big circle C1 is 5, so 5 plus 5 is 10. So if you do square root of 82 plus square root of 82 plus 5, okay, now we have to give the answer in set notation. So set notation, we can write it as, so for this end you can write k semicolon, then square root of 82 minus 5 is less than, so k is greater than this, and then we do this, and then we use the intersection sign, and then we do k semicolon square root of 82 plus 5, so k must be less than this. So this is the final answer. So let's have a look at the answer. Yeah, this is correct. And in set notation, yeah, we should have written k less than square root of 82, but it's the same thing. Yep, that's it. Question 15. The curve C has equation x plus y cube equals 3x squared minus 3y minus 2. Find an expression for dy over dx in terms of x and y. Okay, so this is going to be an implicit differentiation, so let's give a try. So x plus y whole cube equals 3x squared minus 3y minus 2. So one option will be to expand x plus y whole cube and then differentiate. The other option is we can just differentiate as it is. So let's differentiate both sides with respect to x. So when we differentiate both sides with respect to x, we can write it like this. So the differentiation of x plus y whole cube will be 3 times, we assume that this is like x plus y is like capital X cube, so if you differentiate, it will be 3 times x plus y whole square, and then you differentiate inside, so it will be differentiation of x will be 1 plus differentiation of y will be dy over dx equals 3 times 2 is 6x minus 3 dy over dx. The differentiation of 2 will be minus 2 will be 0. Okay, now let's expand this. So we keep x plus y whole square as it is. 3 times x plus y whole square plus 3 times x plus y whole square dy over dx. 6x minus 3 dy over dx. Now let's move dy over dx to one side and all the other terms to other side. So let's move the 3 dy over dx on this side and take dy over dx common. Let's do it in 2 steps. So, and we take this one to the right hand side. So this you can write 3 times x plus y whole square dy over dx plus 3 times dy over dx equals 6x minus 3 times x plus y whole square. One thing we can do here to make it simple, let's divide both sides by 3. All the terms will be divided by 3. So 3 divided by 3 is 1, 3 divided by 3 is 1, 6 divided by 3 is 2, 3 divided by 3 is 1. Okay, now let's factorize this side. I'm going to write it at the top. So dy over dx in brackets x plus y whole square plus 1 equals 2x minus x plus y whole square. And then dy over dx will be 2x minus x plus y whole square over x plus y whole square plus 1. So that's the answer for the first part. So this is also the gradient of the tangent drawn at any point on the circle. This is like a function. Okay, we can check the answer quickly. So 2x minus x plus y whole square over x plus y whole square plus 1. So that's correct. Okay, now part B. The point P10 lies on C. Show that the equation, so that the normal to C at P has equation this one. So this is the gradient of the tangent. So let's work out the gradient at this point 10. So at point P10, dy over dx will be, we just substitute the value of x as 1, y is 0. So it will be 2 times 1 minus 1 whole square, y is 0. So 1 whole square plus 1. So this will give you 2 minus 1 over 1 plus 1, 2. So half. That means this is the gradient of the tangent. So that means now if you think about, let's say this is the tangent, okay, and the normal is a line which is perpendicular to the tangent, and let's say this point P is 10, and the gradient of this is m equals half. Therefore the gradient of this line normal will be -2, which is negative reciprocal. Now if we write y equals minus 2x plus c, and then let's substitute the point to work out the value of c. So x is 1, so it will be minus 2 times 1 plus c, and y is 0. That means c will be 2. That means the equation will be y equals minus 2x plus 2. So this is the equation of the normal. Okay. Yeah, that's what we were meant to prove. Now prove that the normal to C at P does not meet C again. So that means we need to solve this equation simultaneously. So one of the solution is 10. So let's substitute. So we have to solve this and the curve simultaneously. So let's substitute y here. So x plus y. Y is minus 2x plus 2 whole cube equals 3x square minus 3 times y. Y is minus 2x plus 2 minus 2. Okay, so this becomes x minus 2x will be minus x plus 2 whole cube equals 3x square minus 3 times minus 2 is plus 6x minus 6 minus 2. Now when you expand this, so you can use minus x plus 2 times minus x plus 2 times minus x plus 2 equals 3x squared plus 6x minus 8. Then this is minus x plus 2, and minus x times minus x is x squared, and minus x times plus 2 will be minus 2x, minus plus 2 times minus x will be minus 2x plus 4. Okay, then this becomes minus x plus 2 times x squared minus 4x plus 4, x squared minus 4x plus 4. There may be a simple method, but let's figure out with this one if we can solve this. So this is 3x squared plus 6x minus 8. Now let's expand this. So minus x times x squared will be minus x cubed. Minus x times minus 4x will be plus 4x squared. Minus x times plus 4 will be minus 4x plus 2x squared minus 8x plus 8 equals 3x squared plus 6x minus 8. Now this becomes minus x cubed. 4x squared plus 2x squared will be plus 6x squared. Minus 4x minus 8x is minus 12x plus 8 equals 3x squared plus 6x minus 8. Hopefully I haven't missed anything. Okay, now you have bring everything to one side, so minus x cubed, and then 6x squared minus 3x squared will be plus 3x squared, and then 6 minus 12x minus 6x minus 18x plus 8 minus 8 becomes plus 8. 8 plus 8 16 equals 0. Let's multiply by minus 1 both sides, so it becomes x cubed minus 3x squared plus 18x minus 16 equals 0. Okay, now we know that one of the solution is x equals 1. So if you put x equals 1 here, that would give you 1 cubed minus 3 plus 18 minus 16. So 1 minus 3 is minus 2. 18 plus 2, yeah, so that's correct. So that means one of the factor is x. So this is a cubic equation. We need to solve it. We can either use calculator here, or we can do it by ourselves. So if one of the factor is, so if x equals 1 is a solution to this equation, then one of the factor of, like when you factorize this, one of the factor will be x minus 1. So let's divide this by x minus 1 to work out the remaining factor. You have x cubed minus 3x squared plus 18x plus 16. So we do x squared times x will be x cubed minus x squared. Then we subtract, so this becomes cancel. Minus 3x squared plus x squared will be minus 2x squared. Bring that down, 18x plus 16. Then we do minus 2x, so it will be minus 2x squared plus 2x. Then you subtract again, so this becomes 18 minus 2 is 16x plus 16. Then we do plus 16. Okay, so something is not right there. 16x plus 16. Oh no, sorry, this was minus 16 here. My bad. So if you do some mistake in the exam, if you do it correctly, then you will be able to figure out yourself. So this will give you 16x minus 16, subtract, cancel. So one of the factors is x minus 1, the remaining factor is x squared minus 2x plus 16. Now you have x minus 1, and then we have x square minus 2x plus 16 equals 0. So this one looks like it is not factorizable, so let's do a complete square form for this. So x minus 1, and then this can be written as x minus 1 whole square minus 1 whole square plus 16. So x minus 1 times x minus 1 whole square, this will give you minus 1 square is 1, so minus 1 plus 16, so plus 15. So looks like either this is 0, but this one looks like it's always going to be greater than or equal to 15. So you have only one solution. That means the line, the normal, will not intersect the curve again. So there will be only one solution, which is x equals 1. That's it.